All right. We are live. Hello, everybody, and welcome to the stream. Hope everybody is doing well tonight. We are, of course, going to pick up where we left off on the last stream. As you see here on the screen, we actually have things up and running, which is great. We kind of did in the last stream, although there were some issues with it, and most of those issues have actually been resolved offline. So we'll go over that in just a second, but before we do, I do want to just take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Lazaran, followed by our partners, Gobolis Inc. and Matt Osgard. Those are the top tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters that you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It means a great deal to me, and it helps me cover and offset the costs of running the channel, things like software licenses, hosting fees, other miscellaneous expenses that come up, eventually assets, things like that. So thank you very much for that support. I greatly appreciate it. However, I would be in error if I did not give a big thank you to all of you, the viewers, whether you're catching us live here on YouTube or on Twitch, or if you're catching the VOD after the fact. Thank you guys very much for being here. I appreciate each and every one of you, because without you guys, this channel and thus this project would not exist. So thank you guys for being here. Okay, Maget's good to see you over there on the Twitch side. Zaka, hello. How's it going? Hope you're doing well. Okay, so now for what we've kind of done off camera, we can see here that things are looking a lot better than they did on the last stream. So I've actually straightened out a bunch of little issues that were sort of remaining with the renderer, and it's actually looking pretty good at this point. So now we're kind of in the mode where we want to start kind of cleaning things up. Going through and kind of, optimizing where we can, and really getting this as trimmed down as we can before we kind of move on. So on the last stream, we didn't have meshes rendering correctly. We did fix that. We did have some memory issues that we fixed on the last stream. However, we had some weird things like the skybox wasn't rendering. We didn't have our refraction and reflection working. And if I get here close to this cube, you can actually see I've got that stuff working again. So a lot of that was just kind of setting some of the dynamic state stuff, which we're going to go over in just a second. We weren't setting that in some places where we should have been. So this is actually coming along a lot nicer now. It's looking pretty good, I think. We also got our shadow mapping fixed, so we can see it there on that. We can see that this shape is casting one there, and we can see that our transparent shadow maps, or our transparent geometries rather, or materials, are casting the shadow as they should be. The only reason that this tree is not, this looks a little bit weird because the shadow is not meeting the tree trunk, but that's because it's actually a little bit off the surface of the water, right? So I could probably fix that, but I'm not really worried about it. It's just a test to make sure that our transparent materials are working as expected. So if I flip through the various lighting modes here, we can actually see all those things working as we expect. We should be good to go on that. One thing I do want to point out is these cubes, these sort of test cubes here, look a little bit weird, and you'll notice that the normals on them are messed up. So I'll probably have to re-import those at some point. They've just got some really wacky normals, and that's kind of the reason that they're not really handling shading correctly and all that, right? Is because, if you look at a mesh like this tree over here, its normals are correct, and kind of give us the result that we'd expect, but these guys aren't correct. So don't worry too much about that. That's just a simple re-import issue that we'll fix, probably offline. Okay, so to get us to where we are now, we did a number of things. Most of it was sort of just bug fixing. here and there. In fact, I can just kind of go through some of the files here. Now, there are 16 files listed here. I should mention this includes everything from the last stream too, so I haven't actually pushed this up yet. And that's because there's a couple more things that I want to do. The biggest changes are in the Illumina renderer. So we kind of got rid of a lot of this viewport stuff that's in here, and we kind of just do it manually from now on. So the other thing is we don't use a rect 2D anymore. We actually introduced a new type called rect 2DI, and that's because viewports and scissors actually deal with integers under the hood. And so we should be using integers to represent those things. So in our math types, we've added a new, it's just the type def of a vector 4i to give us a rect 2DI, right? So it's just an integer-based 2D rectangle. So we have that. And most of this is just me kind of converting over to do that, adding comments here and there as to what we're doing. And then I went through a lot of places and actually updated and made sure that we were setting, depth state correctly, setting culling correctly in the places where they should actually be set within the rendering routine, right? And so again, we have here in the render frame, we actually have a whole bunch of stuff being set at the very beginning of the frame now. So this is something that was sort of being done by the rendering backend, and I decided to move it out of that because it's making a lot of assumptions that we probably shouldn't be making in the renderer backend, right? So we've actually moved all these to the Bespoke application renderer. So it's things like enabling depth state, using backface culling, setting the winding order, setting the clear values for the depth and stencil, setting the default stencil operations, turning off stencil testing, setting the right mask, and the reference for the stencil buffer, right? So all of these things were kind of being done for us automatically behind the scenes in a few places in the renderer. And I've gone ahead and decided to strip those things out. And actually, we need to finish that out as well. Because we are kind of transitioning to having less of an automatic approach for the engine and more of a application-centric configuration of how the renderer is supposed to work, I've gone ahead and decided that this kind of stuff is the kind of stuff that we should not have in the renderer backend, right? And so the rest of this is just kind of me setting some of these things where they need to be set, the viewport, the scissor, the cull mode. All of this is just kind of repeat in the depth state. The other thing is I noticed that in our shadow pass, we weren't rendering opaque geometries for some reason. For some reason, I only did transparent geometries. So I went ahead and added that in. It's essentially a copy pasta of this logic here. We'll tighten that up at some point. And then just changing things over to a rect 2DI here again. So a lot of just that kind of thing. And then also we were, instead of sort of using a viewport struct as we were kind of doing in a lot of different places, that isn't really going to be something that we're going to be using going forward. In fact, we're going to take it out on this stream. So our viewport dimensions are almost always going to be based on the dimensions of whatever texture we're rendering to. And same goes for the scissor. And if we need to change that at any point, we can know to change that in the Bespoke renderer, right? So we've gone ahead and switched over to that. Again, just being a little bit more explicit, a little less automatic about some of these things. And again, more of the same changes here and more of the same changes here. And so this is the gizmo pass, the editor gizmo pass, and this is the debug pass, right? So more of that. And then the standard UI kind of got the same treatment. So it looks like a lot of changes in here, and it kind of is, but like a lot of the changes are the same sets of changes all the way down. All right, let me see. Payne over on the YouTube side. Hello, how's it going? Good to see you. Let's see, over on the Twitch side, Sikelos, good to see you. Yeah, welcome. Get wrecked. Yeah, exactly. Just curious, how do you handle Swapchain resizing? Do you do the approach that's shown in the official sample on Swapchain resizing, or do you do the best effort approach that basically everyone else does? I guess I'm not familiar with what the best effort approach is, but the way that we handle it is I essentially have a whenever we trigger a resize event, which comes all the way down from the platform layer and the windowing system on that platform, we send an event, and that event is picked up by the application. And the application at that point goes ahead and tells the renderer, hey, we need to resize the swap chain, or hey, this window has resized. And then the renderer backend says, hey, we need to resize the swap chain. What that does is it ticks on a flag in the renderer that says, hey, the swap chain is resizing. And that will keep it from actually running through a render routine until that is finished, right? So we can continue updating the game, we can continue doing things, but we hold off on actually rendering anything until that swap chain has actually completed being recreated. So essentially what we do is we create a new one, we tear down the old one, and we just replace the images where we need to. Basically, it's somewhat complicated to resize a swap chain correctly without an extension, since it's unclear when the swap chain is actually finished presenting. Yeah, so what I also do to get around that is, here, let me actually just run this. Because you can actually kind of see in the logs what happens, right? So as I resize this, right, we're not really doing anything yet, right? It's not rendering, it's just kind of just hanging out, right? We kind of pause the rendering process while we're doing this. And then as soon as a certain amount of frames has passed where we're not changing the size, we keep track of that as we're resizing, right? So I'm continuously resizing here. As soon as I sort of let this go and then a certain number of frames passes, that is when the actual swap chain resize kicks off. Now that I've said that though, this is the time when my graphics API or my graphics card decides, there it goes. Okay. It was probably because I kept doing it for so long. But essentially, it's supposed to wait about, I forget whether I set it to 30 or 60 frames. And then it actually performs the resize. So if we look in our logs, we can see here, render Vulkan render backend resized. We have a width, height, and generation of the swap chain images. So here is our new size of our window, and then it just kind of does the thing, right? So if I resize it again, it just kind of does it, right? And you can see that we maintain the generation. So every time we update that, we just kind of keep track of how many times that's changed. And this resized rebooting or resized booting is basically us booting out of the draw procedure. So we essentially just, we just hold off a certain number of frames until we're certain that we're done resizing, and then we go ahead and create the, or we resize. The reason I do that is because these resizing events kick off so fast, one after the other, that if you try to kind of keep up with it as you're resizing, and you try to just continuously, recreate swap chains, you're going to eventually have an issue where you're not going to be able to create them fast enough to actually keep up with your window resizing, right? So the drawback to that is, yeah, it takes a second, right, before you actually get the new image presented to the screen. But like, how often, real use case, real talk here, do you really need it to be instant as you're sort of resizing the window? Now, granted, we have an exaggerated delay on this just to kind of keep us safe, right? I would imagine probably in the production version of this, I'll probably trim that down some, but like, I don't think it's a huge deal to have a small delay to avoid all the issues that come with trying to do it instantly. I don't know how DirectX 11 does it, but it's very smooth resizing. It's probably tied in with the Windows system. I don't remember, though, completely, to be completely honest with you. Seems sane. Didn't really need the ability to continuously resize the window for a game. Yeah, exactly. The official sample recommends keeping track of older swap chains and the resources until you're absolutely sure it's done presenting. Yeah, so what I do is to avoid that issue, as soon as you start resizing, it stops rendering. So you're definitely going to be done. Between that and the amount of frames that it waits after you're done resizing, you're definitely going to be fine. Thank you for the follow, by the way. It's no worse than the delay in Firefox when switching tabs. Jeez. Ouch. Can't you use external images for Swapchain? Could you just allocate like a large image that you subrect, basically? I mean, I could do that, right? But you'd still have to create it anyways if you grow the window too large. So it's not really worth it, right? And we do, like in this engine, we don't actually render to the Swapchain images anyways. We blit to it. Hence the stuff you see in here about blit destination, right? So we actually render to a different set of images that's also kind of kept by the Windows / the rendering backend. And we render to those, and then we blit to the Swapchain. So the Swapchain image is the only thing that ever happens to the Swapchain image for us is we blit to it. So it's never, sort of held up for very long. Problem is that you can now, when it's done rendering with a fence on Q submits, but there's not a fence for the Q present, so you can't actually know when it's done presenting. Wait, what? No, can't know. Let me reread that, because I think my dyslexia just slapped me upside the face there. The problem is that you can now, when it is done rendering, okay, you're saying now you can know that it's done rendering because of the, wait. Because there's not a fence for the QPresent, so I can't actually know when it's done presenting. So we don't actually run into that issue, right? Because presentation is actually pretty quick. So by us switching off the render and say, hey, we're resizing, even if that presentation takes a couple of milliseconds even, because we are kind of doing a bunch of, we're still sort of doing the update loop, but we're not actually running through the render loop. Because we're doing that, it's got more than enough opportunity, because we don't actually do anything in terms of the swap chain, like recreation or whatnot, until after we stop resizing the window. So by that time, it's already definitely presented. It's definitely done presenting. It looks like we have a little bit of a bug here on this platform with how long it actually takes to complete that. So I may have to look at that. I'm not sure why it's delaying quite so long in some cases. It did eventually come back, though. I should probably quit messing with it. I'm just going to kill it. Anyway. Let's see. Spy that neon mage in the background. Are you a Final Fantasy fan? Yes, big time. Absolutely. First time chatter, by the way, welcome. New to the coding world, currently learning C. Awesome. That's a great place to start. Yeah, so that mage back there was actually a gift from my wife. And I absolutely love it. If it wasn't so tightly cable managed, I would bring it a little closer to the camera so you could see it. But I guess I could switch to that so you can kind of see it a little bit better. Yeah. But yeah, it's cool. I love it. You know the theoretical limits of your desktop size, but that could be the upper limit of the Swapchain images. So the problem with that, Magets, is what if you have, like, I've got a setup here where I have 4 monitors, right? The theoretical limit on that, especially since 2 of them are 4K monitors, is huge. Way larger than I would ever want to create an image, right? So I think anything that you would save calculation-wise by trying to do that, you would just lose in terms of like keeping this massive image in memory and writing to this massive image that you're not using the entire thing. So I don't think there's much gain there. Apotham, how's it going? Good to see you. Let me retype that. The problem is you can know when it's done rendering with a fence, but you cannot know when the presenting is done. Right, but again, because of the way that we do it, it doesn't matter when the presenting is done because we actually wait a number of frames in the update loop before I try to render again. So we actually wind up being in pretty good shape, I think. I do have a couple things that I want to look at in terms of that I do want to tighten up a little bit. But yeah. Only really an issue for continuous resize stuff. Exactly. Yep. Let's see. Okay. There's a new extension that adds the ability for There's a new extension that adds the ability for the Swapchain to signal fence when it's done presenting. The problem with extensions, though, and this is why I don't use a lot of them, is because hardware support is an issue. Did you figure out the scissors thingy? Yes, I did. Yep, it's all figured out. Yeah. So I figured it out offline. Essentially, I just wasn't doing it in enough places, and other places I was doing it too much. So, yeah, I did figure it out. Sergeant Pepper, how's it going? I did actually not see your message until actually I quit the stream last time. So I hope you're doing well, though. All right. Anyway, so I also went through and clobbered a bunch of code in some of the render graph nodes that I don't really need anymore. What else is part of this diff? I think that's really it, right? It's basically just been me sort of bug fixing, right? So we've already gone over that. I did, however, go through and remove the viewport structure from all of the different passes, right? So the shadow pass, the forward pass, the standard UI pass, the world debug pass, and the editor gizmo pass, right? So we're not using these viewport things anymore, and I actually want to get those out of code tonight. And that's kind of what I have for tonight. So I want to talk about this a little bit. So the way that we handled this before is we sort of created 2 different viewports. We had one for what we called the world viewport, which is what we use to render to, the world. So, it contains our projection matrix, or our perspective projection matrix, rather. It contains our FOV, things of that nature. And then we also had a UI viewport, right? And this is kind of where I was thinking, like, it doesn't really kind of make sense the way that these are grouped together. So this is another one of those things where we tried it, but I'm not really a huge fan of how it turned out. So we're going to eliminate these, and we're going to replace them with a combination of a couple things. It is a family-friendly stream. Yeah, it is, Sergeant Pepper. I was just using that to show the diff. But yeah. Thank you for the follow. Appreciate that. Singy, how's it going over there on the YouTube side? Okay. So where we left off is basically to remove the viewport from our code. So I've already done a decent amount of that as far as the game code is concerned. But there is this sort of block here that I want to talk about that is taken directly from the viewport itself. So this is a projection matrix regeneration function that's internal to viewports, right? And the way that it essentially works is it takes a projection matrix type, and based off that type, it creates the appropriate type of, projection matrix, whether it's orthographic or perspective, right? So there's two types of orthographic. There's one of these that's called centered, and then there's one of these that is basically just a standard orthographic projection matrix. So the centered one just does a little bit of work to, actually, I don't even know if we're using this one. I don't think we are. That's my example code. That's the regeneration function. That's a check for it. So we're not even actually using that. To be completely honest, I probably am just going to get rid of that because I don't think we actually need it for anything now that I think about it. Let's do that. The idea is that the matrix was centered around the width and height instead of zero based, right? And then you could use an FOV as a zoom. I guess we could leave it. I don't know. It's not a bad thing to have, but essentially what I want to do is I want to move this to sort of a utility function so that we've got it available, right? So we have renderer types. Let's see. So don't we have render type utils. I suppose we could put it there. Right, maybe we'll just go down here to the bottom. And we'll do, let's see, it's going to return a mat4. And we want to say, let's see, generate projection matrix. Right? And the parameters that I want to have it take in, let's see, actually, I should probably do, actually just take, yeah, I'll do it from viewport create. And we'll get into why that is in just a second, right? So let's paste this here as a example. So let's do that. And then obviously we don't want to create a viewport, right? We're just interested in generating a projection matrix. So we don't need this. And let's see, this is, I guess I should probably include this in the header file. So let's go over to the header file. Right. Okay. So we'll do export of the symbol and then that. We don't have render a projection matrix type. Why is that? Oh, this is in core. I'll bet we don't have, I'll bet that's in runtime. I'll bet that's in runtime. It is. Cool. I think this is something that's acceptable to move to core. Right, so I guess let's go to core render types. I guess let's just put this, actually let's put this towards the top. Let's see. Topology, pixel formats. Okay, before texture stuff. Before pixel format, probably. Let's, yeah, let's put that up here. Actually, yeah, let's put that all the way to the top. Okay. Don't need that. All right, so now that we have that, we have what we need here. Okay. I don't know why this isn't disappearing. I've got to figure that bug out. Okay, so based off a rectangle, which should probably actually be a rect 2di, which means this needs to be a rect 2di. Let's see, we have FOV, near clip, far clip, and then the projection matrix type, right? So based off of this, instead of what we're going to do here is instead of having this pointer everywhere, we can just do, you know what? It should probably be a switch. I don't know why I didn't do it that way. Let's do a switch on projection matrix type. Thank you for the follow. Appreciate that. So let's populate the switch, and then we'll do a default of perspective, right? That way we don't have to repeat ourselves. So we can use this one here. I've got a note on this one. Not sure if I need to do that even still. I wrote that logic probably years ago at this point, so I don't fully remember. All right, so we can get rid of all this. And instead of doing V projection, all we're going to do, is we're going to return it, right? So if I can spell return correctly anyway. There we go. So we're going to do that. And then obviously instead of, having the V pointer everywhere, we're just going to do this. Now, the aspect ratio for this one is going to have to be casted to at F32 for one of them, so that we don't lose, so that we don't round on division there. Okay, so we can get rid of this. Okay, that's the orthographic. And then, wait a minute, why do I have... I don't think I copied that correctly. And I already removed it from there. Viewport. Centered should be this one. Yeah, okay. So this one should be that. Okay, so we have the FOV, and then here we're doing return. Remove these. Why is it bleating about this? Okay, we don't need that. Label followed by a declaration. Oh, okay. It doesn't like that. So I've just got to do that. Okay. So that is our function to regenerate, or to generate rather, a projection matrix based off of a rectangle, FOV, near clip, far clip, and projection matrix type. So that way we don't have to remember to do all this stuff all over the code base, right? We could just kind of use that from anywhere. So now we can go back to Illumina main, and where we're doing this viewport create, we can actually just kind of do this, split some of these properties out, right? So we have this app state world viewport, and UI viewport, right? So those are the things that we want to get rid of. And so I'm going to use, let's do a mat for, I guess I'll do world projection. And then the FOV and the resolution and all that other stuff, the rectangle, I'm going to get from the camera and or the frame buffer, right? So we really just need that and then mat for UI projection. And then we can delete those two. Right? And the camera really should be storing some of these properties, right? So, you know, things like what our FOV is, our near clip and our far clip really ought to be held as part of the camera. And then we could also theoretically store the projection matrix type as, you know, within the camera as well. So theoretically, we could pull all of these properties from the camera and then generate the projection matrix based off the camera that we're using, right? And I believe we already have, don't we have, do we have a default camera in here? I don't remember where or how we did that. Right here, editor camera, cameras, okay. Right, so camera system acquire world, current camera, okay. So I think, like we were talking about our camera system and potentially getting rid of that. I'm actually now thinking about like extending it. Let's see. I had an SSD failed on me, so I decided to upgrade NeoVim to 0.11, and I only had to make one change to my config to get it back in working order. Nice. That's pretty awesome. That's so interesting that you had an SSD fail, because like that was the reason I missed a stream last week. Or I think it was last week. Is because my main SSD failed on this machine, but thankfully I had another one that was in another machine that wasn't actually really being used. So I was able to steal that one and get back up and running. But yeah, I lost a decent amount of work, a few hours of work, and all of my files that were on it. But I had most of my stuff backed up, so it's not that big of an issue. But yeah, been there, done that. Feel the pain. Hey, man, how's it going? KJC, first-time chatter, welcome. It is going well. Thank you for asking. My wife is in on that VS joke, and she saw it open today when I was working and gave a sigh and told me to get that filth off my screen. Yeah, I mean, that's fair enough. Trophy wife, definitely keeper. I would agree with this. Yeah, I would totally agree with that. Okay, so what we need to do here is to do store FOV projection matrix type, which will be camera type, driven by camera type. We'll come back to that in a minute. Near and far clip. And then generate projection matrix based off camera properties, right? So what we have here, I think these are, oh, this actually, I shouldn't do this here. I should do this here. Thank you for the follow. I appreciate that. Welcome. Lou the Coder, good to see you. Will the current Shadow of Illumina state be the default testbed example? I kind of like it. Before you actually start working on your game, since you mentioned you won't make the code public for it. Yes. Yeah, so that actually is the plan, right? And that's the reason why I want to spend a little time cleaning this up and kind of making it nice and clean and easy to kind of understand and use and full of comments and stuff like that, is because what I'm going to do is I'm going to pick up the implementation that I've got here, and I'm going to translate all that stuff over to the testbed so that the testbed is a working example of that. And I'm probably just going to delete the other project, the Overdrive project, or I'll maybe move it to a different repo or something, but I'm going to get it out of the Kohi code base. But yeah, so as soon as we have, there's one more big thing that I want to do after I get this sorted out before we do that. And that is the scene refactor, right? But then I'm going to use that as the template for sort of the testbed project. Kuju raiding with a party of 56. Thank you so much for the raid. How's it going, Kuju? What did you get up to on stream? For those of you who don't know who Kuju is, he is working on a really awesome looking game called Fat Goblins. It is written from scratch in Jai. It's a really fantastic looking project. I highly recommend. Not only do you give him a follow, but go check it out. Wishlisted on Steam. It really is looking very, very awesome. Finally made a really fancy icy shader with distorted fish beneath it. It was really hard. That's super awesome. So what I'm up to today is we are actually simplifying our code base. We're actually making things less generic, which I know sounds weird, but I've actually been sort of going like, hey, these systems are a little bit more complicated than they really need to be. Let's simplify it, right? And one of those things is the renderer. So we had this whole render graph set up, which was cool. It worked well. But, you know, there's overhead associated with that. So I went ahead and just said, you know what? We're getting rid of it. So we are going to have a bespoke renderer for at the application level, and that's going to drive the rendering process, right? It'll reach out and make all the API calls to our rendering backend that we need. And the reason for that is because the application or the rendering process is application specific, right? The application knows what data it's dealing with. It knows how that needs to be transformed. It knows how it needs to be organized, and how it needs to be rendered. And so trying to like make all that stuff generic was just kind of a pain in the ass and a lot of overhead. So, you know, we had it working, but I'm just like, no, I don't want to do that anymore. So we're making it less generic, and we are making it application specific. And so that's kind of what we're finishing up doing at the moment, because we're going to take this game code that we've set up for the Illumina project, which is the game that I'm actually making, and I'm going to translate that into the default template that also comes with the engine. And that's essentially what we're doing. Thank you guys so much for the follows. I really appreciate that. Let me catch up with chat. Let's see. Shadows of Illumina is greater than Overdrive. I agree. Shadows, I'm here. Frozen Shadow X, first time chatter. Welcome. Okay. Hello world from Penguin. I appreciate that. Welcome. Thank you guys so much for the follows. I really appreciate that. And again, big shout out to Kujo. I need to catch up on your VODs actually. Cato Pixel, hello, welcome. All right. So one of the things that we are simplifying is we had this kind of concept, this weird amalgamation of kind of mixed concepts called a viewport. And the viewport represented like a sort of a draw area that we could use to generate the actual Vulkan viewport from and the scissor. And then it also kind of contained a projection matrix and other weird properties like FOV and stuff like that. And I've decided to get rid of that as well in favor of something that's a little bit more organized and I think makes a little bit more sense. Something that we already have, which is going to be the camera. So I'm reworking that now to, again, remove more code that I'm actually adding in an effort to simplify the code base. Got to dip real soon. Yeah, definitely. I mean, don't worry about the raid and run. I totally understand that. I do it all the time too. Go get some food or whatever it is you got to do. I really appreciate the raid and thank you for being here. I definitely appreciate it. Okay. So, what we were saying was, we've essentially got this camera system already, right? Where we acquire a pointer to a camera. And that may or may not create a new camera behind the scenes. In fact, I probably need to update that because that's dealing with raw strings, which is not great. And then, we can set the position on the camera or the rotation. And so we really need to be able to set some additional properties on it as well. And so I could do these as individual properties, which is fine, but I think it might be nice to actually have something that we could set up like all this stuff in one fell swoop. Thank you again for the follow, guys. I really appreciate that. Thank you. Let me see. Over on the YouTube side, we got a couple comments there I need to catch up with as well. That's insane. I'm here right now doing a small 2D game in Raylib/C and struggling, and here's this guy's doing a Vulkan C engine. I mean, hey, I've been at it for a while, right? Plus, I'm a glutton for punishment, so I like doing things the hard way. At least you're building stuff, and I think that that's awesome. So never, comparison is the thief of joy, as they say, right? So, don't look at what I'm doing here and become intimidated by it. Become inspired by it instead, and look at this as maybe a target that you can work towards. And keep learning, keep doing, keep writing code, keep making awesome things. And if you want to, you can get here. It's totally possible. If I can do it, you definitely can. Sorry for the weird question, but any tips for growing and maintaining a beard? No, not really. I've just kind of let it grow. Like, I do trim it every once in a while, but I'm trying not to. Because I have a deal with chat to not cut my beard off until the game is complete. Yeah. I don't know. Condition it every once in a while. Make sure you clean it every day. Yeah. Thanks for your advice, made my day. Awesome. I'm glad to hear that. Thank you guys for the follow. Appreciate that. Are you making a rendering engine only, like a framework, or it also has physics and interface stuff? So it's a full game engine. So it's not just a renderer, right? This is one part of it, right? So we have the engine, which is sort of a library that we program our game code against, but also a suite of tools, or at least it will be. It kind of already is, but we're still kind of building that. And then we have, the game specific renderer, which is essentially what tells our engine's rendering library how to actually draw stuff and what order and all that stuff. But yeah, we do have like a sound system. We haven't written a full physics system, and I actually don't need one for the game that we're writing, so we're not going to do that yet. We're just going to write what we need, and that's been kind of the theme with this so far. Is we're only writing what we need, although we are trying things out along the way. But yeah, we do have an interface. We do have a user interface as well that we've written from scratch. Let me see if this will even run it. I don't know if I've actually tried to build this or. Yeah, so we do have like a small user interface with like text boxes and stuff like that. Nothing too fancy, right? We've also got buttons, which I don't actually have an example here to show you in this project, but it is not just a renderer. It's actually, it's got the systems you would expect, right, from an engine. Let's see. Judging by how much time it took Casey to make Handmade Hero, you better like your beard. Yeah, I mean, well, okay, so for perspective, I have been at this for 4.5 years, but with less than part-time hours. So I put a maximum of about 10 to 15 hours a week into this. If I were working on this full time, it probably would have taken me about a year to get where I am at. Maybe. So yeah, I mean, I kind of wish I could work on it full time, right? But you got to pay the bills. So you're making a whole engine, but the programming language for the engine itself will not be C. The programming language for the engine itself is C. Yes. We have DLL, hot reloading, and all that stuff for the game code. Yep. So C is the scripting language, if you want to think of it that way. Yeah. Okay. All right, so we need to think about... I'm going to just take a copy of this camera over, because we need to think about how we want to sort of change the way that our camera acts, or what data it holds at the moment, right? So right now it's just basically almost like a property bag. It's not really much more. So we have a position, an Euler rotation, which is, yaw pitch roll, or pitch yaw roll rather. A dirty flag, which is just used internally for whenever position gets set to regenerate the view matrix. And then we also have the transform itself, which is used for the actual movement of the camera, right? So we maintain those separately. And what I'm surmising is that we add a couple more properties here. So we have F32 FOV, and then we have projection matrix type, which I'm actually thinking we probably shouldn't call it projection matrix type, right? We should probably call it camera type, because if we think about it, our projection matrix types are orthographic projection, or orthographic projection, orthographic centered projection, right, which acts a little bit differently, and then perspective projection. But really, what we're looking for is, like a camera type. And then maybe with a flag that, says camera, like, centered or something like that. I haven't really decided, right? So really what we need is type def. We'll do enumeration, and I'll do camera type. Wow. Typing is hard tonight. However, misspelled type def also. However, one of the things that we've also been doing is kind of getting rid of things that are just generically named like camera, or things like texture, or things like that might potentially collide with another library if somebody ever wanted to, bring another library into this. We've been prefixing a lot of this stuff with K, right, for Kohi. And so since we're creating some new stuff here, and since we're kind of overhauling cameras anyways, I think we probably ought to just rename this stuff to K camera, right? And so here, what we're going to do is we're going to have K camera type. And I guess we'll do, let's do 2D. And then K camera type, if I can hit the right keys, 3D. Right? So this one will use orthographic projection. And this one will use perspective projection. Thank you guys for the follows. I really appreciate that, by the way. Appreciate that support. It means a lot to me. Thank you. All right. So I think these are the two types I'm going to support now. If I want to change like 2D centered or something like that to represent that other type, I think I'll do that separately. So let's go ahead and plug this in somewhere. I guess it doesn't really matter where. We'll do it here at the top. K camera type. Type. I'm also going to change this to K camera. And I'm going to come down here and change this to K camera. It's going to break a whole bunch of stuff, but that's fine. And I'm going to up this version to 2. And let's change the date on this. Oops, 2025. What is it? 7/24. Okay. And then also this. Okay. Since we're changing it, since we're overhauling it, we might as well do that, right? Okay, so we have the camera type, the FOV. We need the near clip, so we need F32 near clip. I'm going to call it near clip instead of just near, and F32 far clip. Pretty obvious what those are. Okay, and then what we can do is we'll have a, let's see, Mat 4 projection. And let's see, should we do, I think I'm going to flip the dirty flag whenever any of this stuff gets adjusted as well, right? And actually, you know what? Now that I think about this, we probably ought to internalize this K camera type. Instead of using pointers, we probably ought to use IDs like a lot of our other systems do. And then just retrieve these properties via function calls. Because that's going to make our external interfaces in our game code a lot easier to use, because then we can just refer to everything by ID. We can refer to everything by ID. And then we don't have to keep like pointers to it around. We don't have to worry about the structure. We don't have to worry about what's in the structure if we ever refactor it. We don't have to refactor everything that touches it. So I think maybe that's what we should probably just bite off and do now. Okay, so I think that is actually all we need here. I'm not worried about structure packing or anything like that for now, because we are actually going to be changing this stuff. So what I want to do actually is I'm going to take this. Let me actually go to, why is it not opening? Why is it opening an NVim tree toggle in? Wow, that's weird. Okay. It's opening it in like root. That was weird. All right. Let's do, we got to go into submodules, Kohi, and then we'll go into, let's see, was this in, this is in runtime. Okay. So we'll go to runtime, and then source, and then systems, and then camera system. So I'm actually going to rename this, which is also going to break some stuff. But that's fine. We're going to call this K camera system. Right? And then camera system here, we're going to rename to K camera system. And I'm actually thinking I'm going to get rid of this camera.h out of the renderer, right? And we're just going to use, whoops, did I not? Okay. We're just going to use the K camera system to represent these going forward, right? So we'll do K camera system over here. We're not going to include this. Instead, I'm actually going to switch this back to camera for a second. Oops. And it'll be obvious here in a second as to why. So camera system config, max camera count. I don't know that we need that, right? But we'll keep it for now, I guess. That should be there. Okay, so default camera name. I don't think we're going to do the camera name thing anymore. I think we're just going to treat them by IDs, and we're not going to do, because like naming is like something I've been trying to get rid of for a while now. Instead of renaming, or instead of, you know, referencing things by name, we'll reference them by ID. And if we want a name associated with that ID, we can come up with a structure to associate those two, but I don't really want to have like names floating around. So I'm going to get rid of that. Camera system initialize, that is fine as it is. Shutdown is fine. But the things that are going to be changing is camera system acquire, release, and then get default. So the way that we're going to handle this is we're going to type def U16. Actually, let's do a U8 on that, because I can't imagine needing that many cameras, right? So let's do a U8, and we're going to do K camera, right? And we'll change this to a U8 as well, which is probably going to break stuff. That's fine. So our K camera, instead of being a structure like this, is going to be converted to essentially an ID, which is a lot in line with how a lot of our other systems have gone, right? As you saw, you know, this stuff was originally written back in 2022. This was actually written in 2021 initially. So this stuff has been quite a while since we've actually updated it, right? So we're going to do K camera, and whoops, and it's not going to be a pointer anymore, right? And we're going to do K camera system acquire. Let's actually do something a little bit different. Let's do create, right? And then let's actually, I guess we can leave acquire, right? And then just do K camera, right? And this is going to be, let's see, param name, this is going to be camera. Well, I guess we don't even really need an acquire, now that I think about it. We really only need to create, right? Because the ID is going to be the whole thing. So yeah, this is kind of dumb. So this needs to be create, right? And then we'll kind of do some of the things that we expect here. So we're going to go K camera type, and then we'll do, let's see, what's the next? We probably are going to want rotation, right? So vec3 Euler rotation. If I could spell it right, God. View matrix is generated, dirty flag is generated, transform is generated off of rotation and vec3 position. Oops, position. And then F32 FOV, F32 near clip, and F32 far clip. And that should actually get us everything that we need, right? So when we do this, we're going to say, let's see, let's actually, let's do creates a new camera and returns a handle to it. Creates a new camera using the provided parameters and returns a handle to it, right? So the first parameter is going to be, instead of camera, it's going to be type. So the type of camera to create. So 2D equals ortho projection. 3D equals perspective projection, right? And then we'll do position, param, position. The position, I guess the camera start position. And it's going to be the same for rotation. Oops. Camera starting rotation. And Euler angles. So pitch, yaw, roll. Param. What was the next one? FOV. And then param. Not really much to say about that. Near clip. Param. Far clip. Oops, far clip. And that's it, right? So we create one, we return this K-camera, which is just a type def of a U8. And then K-camera, or I guess it would be K-camera system release. I actually need to change that on all of these. Right. Okay. We'll come back to this one in just a second. All right, so release is just going to be K-camera, camera. Release the camera, releases the given camera. I misspelled internal there. That's awesome. We do have an internal reference counter in cameras, though. We don't really need that anymore, actually, because it's just an ID, right? So when we get ready to destroy the camera, we just destroy the ID. Okay, yeah, I'm not really worried about that. So let's get rid of that, right? So this is going to be the camera to release. Let's call that destroy, actually, because it's not really following the release pattern of like our texture system. And then the default, let's say, gets a handle to the default camera. Same thing here. And this is going to be a K camera, but not a pointer, right? That's going to do it. Let's see. Just noticed your terminal says Arch, by the way, for what system you're on. Yeah. Yeah, I put that in there as a bit of a joke, right? I named my machine Arch, by the way. Just for the lulz. Let's see. You just popped up in my recommendation. Have no idea what you're doing. Can you briefly summarize? Yes. Oh, yeah, I have a lot of chats over on YouTube to catch up on. Sorry about that. So we are, I'm basically revamping the camera system because we had sort of this other sort of viewport system that was holding half the information that really a camera should have been holding. And so we're doing away with that viewport system completely and integrating the changes into the camera system. But the camera system was written years ago and follows a different paradigm than we're following now for all of our different systems. So I'm updating it to follow that new paradigm. And this is part of all of our updates that we've done to the engine for our new renderer so far. Let's see. I'm just going to kind of try and pick out the main questions in here. Is there a reason you're storing Euler angles instead of converting them to a quaternion directly? Not really, because, I mean, just they're easier to use as far as the camera's concerned. At some point, I'll probably swap it to quaternions, but... yeah, I mean, it doesn't really... It is what it is, right? Let's see. Running a game engine C from scratch. Doing a pretty good job at it. I appreciate that. Not sure what C or Vulkan is. So C is the programming language. That's the code you see here on the screen. And then Vulkan is what's called a graphics API. So that is how I communicate with the graphics card that's installed in my machine, right? And I use C code to do that. Thank you for the follows over there. Appreciate that. Vulkan, yes. Yep, we're doing Vulkan in here. And I actually did a little bit of Vulkan programming earlier in the stream, but now we're kind of back to our other external systems. The thing is, I've got a lot of the Vulkan code written, so I don't have to touch it that often. Like, once you kind of figure it out, you don't really have to touch it all that often. My condolences, but thank you for your service. That's funny. Yeah, I mean, you know, I could have done it GL, but like there's 1,000 people out there doing it in GL, so I'm like, why not Vulkan, right? It's honestly, like, I know how this is going to sound. It's honestly not that hard. It really isn't. It's just a matter of understanding all the various things that are going on. If you've done graphics programming before, it's not that big of a leap. Once you have it figured out and most of the main systems sorted, it's not too bad. Let's see. All right, wait, is it Ilhamza? I'm not sure how to pronounce that, but have a good one. Pikuris, it's good to see you too. All right, so we have all of this stuff. So the way that we're going to convert from using this structure to something that is more easily refactored when we have something that we want to add or remove to it is we're going to hide all that stuff behind a system and let the system determine how that stuff is stored internally. Probably for something like cameras, I'll probably just do an array of structures like this internally. I don't think a structure of arrays is really going to help us all that much here. But maybe it will. We'll see. We'll see where we wind up with that. Okay, so we have the create and the destroy. So now we just need a way to get... we need a way to actually get all of the properties that we're going to need. So there's only certain things that we're actually going to need from this. So vec3 k camera get position, right? And then we just do a k camera to that. It's pretty much going to be the same thing. I'm not going to bother commenting this out on stream. I'll do it at some point in the future. Let's do Euler rotation, right? Let's make that super explicit as to what kind of rotation we're talking there. So we need to get the view. We need to go ahead and get the transform, right? And that's just going to be a mat4 as will this. So the other thing we're going to need is get projection, right? So we'll need to get that as well. And then we'll have a couple of other properties that I'm probably going to put up here, quite honestly. We'll do, I just realized I'm coding behind my head here. I'm going to bump that up a little bit. F32, we want to get FOV. And then near clip and far clip. Right. Now, for some of these things, we're going to want the ability to set them, and some of them we're not going to want the ability to set them. So things like view, transform, and projection, we don't ever need to set those things, right? Those are purely things that we want to get. However, position, we should be able to set, right? So we want to do return type void, and we're just going to do set position what camera we're going to set, and then Vec3 position. It's kind of as you would expect, right? We're going to do the same for Euler rotation. And so that's going to be Euler rotation. Same thing for FOV. Whoops, or Fox, that's fine too. So we'll have one for near clip, and then one for far clip. Cool. And that's the entire interface. All right, I don't think there's anything. Let's see, camera copy. I don't think we. Well, maybe we might wind up doing that. We'll see. Camera reset. I suppose we could do that one, right? So after all of this stuff, we could do void K camera reset. And then see a lot of these things we already had. Euler and Euler set radians. Ooh, that's interesting. Okay. I forgot that we had a separate thing here for that. So instead of degrees, we can set by radians. We also have inverse view get, so that's probably something worth. Actually, maybe not worth it. Recalculate view. Oh, literally just returns the transform. Because the view, I think, is just literally the inverse of the transform. Yep, it is. Okay. So I'm not going to worry about that one then. Okay, so we had some other convenience functions in here, which is actually probably something we should keep. So this is actually getting the forward, backward, left, right, up. Do we not have down? Vectors? I guess we don't. That's neat. Okay, cool. I don't know why we did up and not down. That seems fine. Yep. We did forward, backwards, left, right, and up, but not down. I mean, I guess you could argue that down is just the opposite of up. Still. And then we have move forward, move backward, move left, move right, move up, move down, yaw, and pitch, right? So these are all things that we're probably going to want to keep. So actually, I think what I'm going to do is I'm actually going to copy pasta these and just rename them to what I need, right? Because we're going to eliminate this file entirely. We're going to combine all this stuff into one single file. Thank you for the follow. Thank you for the follow, rather. Dr. Elliott, good to see you. Coding behind your, here's some Jimi Hendrix level stuff. Wait, coding behind your head is some Jimi Hendrix level stuff. Yeah. I know, right? Sometimes I forget that this little box here exists, that I can see like this section on the screen, but you guys can't. So I try to avoid doing too much coding over here. I should probably actually do, I should probably do this over here and then do camera H over here, right? Swap it. So that way I'm coding on this side and you guys can't. You guys don't get blocked by that stuff. let's see. This is true. I originally wrote my engine in DirectX 11. I would recommend for beginner GPU programmers. Yeah, that or OpenGL is fine. And the transition to Vulkan, although taking a long time, is not as hard as I thought it would be. Yep, exactly. Definitely some hiccups and some architecture rewrites. Yes, agreed. I would say if you're going to do a multi-backend system like what I've designed here, you definitely should probably start with Vulkan. Thank you for the follow. I appreciate that. Welcome. Okay, so we've copied over all of these functions. So I'm just going to prepend a K to these now. You know what? It's probably quicker for me to just do it this way. I normally don't like using the mouse, but there's not actually a faster way to jump consistently down to the function definition name that I'm aware of. So I'll just do it this way. Okay. The other thing that we're going to do is all of these camera pointer C's, we're going to do a find and replace on those. So camera, I got to remember, do regex here, right? Space C. We're going to replace that with K camera, and we want to do that globally. Cool. And then I suppose we should also, you know, update all of these comments. So let's also do see a pointer to a camera and replace that with see a handle. Handle to a camera globally. Good enough. Not to be confused with our K handles, which is probably going to wind up going away. Hi there, how far is your render in dev? Curious as to what you've achieved so far. Doing VK myself too. Also, love your MVIM setup. Looks pretty good. Okay, cool. Well, first time chatter, welcome. So I actually have an article with my NeoVim setup on it. It's a little bit dated at this point, but it's probably like 90% there. I really need to update that. So that is that setup there. As far as the renderer, I've been ripping apart stuff, but I don't think I've tried to recompile, so I might actually be able to run it. We've kind of got some debug stuff here, right? There's nothing really fancy on the screen. So what we're looking at here is basically just the ability to like move an object around the world. We've got, you know, some basic UI elements here. You know, I can switch to different, you know, between different cameras. We've got some water rendering. We've got shadow mapping, cascading shadow mapping, I should say. That is supporting, opacity as well, right? Opaque textures. We've got a couple of different debug rendering modes, so I can just switch it to lighting only if I want to debug various lighting issues. Or I can switch it to normals mode if I want to see what the normals of the scene look like. I've got a cascade debug mode, so I can see where the different cascades of shadow mapping break up, right? I've got a wireframe view. So there's that. And of course the regular rendering view there. We do have sound integrated, although you guys can't hear it because I don't have it piped through right now, but we do have sound available as well. And we've got a whole asset system that we just rewrote that loads assets asynchronously. So we've got a lot of stuff. It's honestly too much probably to talk about in 30 seconds, but that's just kind of a quick demo of it. The debug modes look really handy. Yeah, they have been. I've solved many an issue with those, and I plan on adding more. Yeah. They're pretty sweet. Do you still work on non-game stuff for your job? Yes, I do. Yep. Pays the bills, right? It's good work, though. You know, it's just not related to this stuff, but I'd rather have work-life balance, frankly. Are you copying the camera into these functions, or is the K camera type def as a pointer? Sorry for being inattentive. So the K camera, itself is just the type def of a U8, right? So really, this is not. It's being converted to be nothing more than an index, right? Or a handle, if you will. And so the way that that's going to work is the camera itself, instead of being a struct that you keep a pointer to like this, which is sort of the old way of doing it, now you're just going to have to pass this around. So you don't have to worry about pointer lifetimes or uninitialized cameras or anything like that. All you have to do is pass around an ID. And one thing that I forgot to add is a define for a invalid K camera, right? And we're actually going to set that to 0, which is not something that our other systems do. But 0 is basically going to be invalid K camera, or maybe even default K camera. So that's always going to exist. So that way your zeroed code always kind of just works, right? Maybe we'll just say that, right? Because the default is always going to be created no matter what. We're always going to create one as we're standing the system up so that we've at least got one. So yeah, hope that makes sense. Is this going to be similar to the transform handle system where properties, rotation, positions, etc. are in their separate arrays? I don't think I'm going to do a structure of arrays for this one. I don't think it's necessary. But the way that I'm structuring it is if I decided to refactor that, it's an internal refactor after I'm done here. So I won't have to worry about it. Trying to get into non-games myself too. Spending a few years working on a WebGL engine. So trying to move more towards that. Yeah, fair enough. There's all kinds of stuff in rendering you can do outside of just games, right? For sure. Okay. So what do we... I think we just really need to fill these out now. I don't think I need anything else in the API. I'm going to fill out these functions later. I'm not going to worry about those. Yeah, okay. So I'm going to need from here down, essentially. I'm going to go to K camera system C and change that first off. Go all the way to the bottom here, and I'm going to paste all this stuff. And we'll deal with that in a minute. Okay, so camera system initialize. This is where a lot of things are going to change because we had all this other stuff to be able to look things up by name. And frankly, just not a fan. It's cool, but why, right? We have all this reference counting stuff. We don't need this. Camera system state, we don't need this, or the hash table stuff. Config we can keep. Default camera we can keep. Do we actually have... I did not rename this. Okay, this needs to be K camera. In here as well. And let's, you know what? Let's just do this. Just to signify it as being different, right? That way I'll see all the different places that are actually using it. Okay, so default camera, I actually don't really need this anymore either. What we really are going to need is we are going to need well, I guess it's going to be U8 max camera count, right? And I can actually, I don't need to hold on to that config, right? And then we'll do, let's see, instead of camera, let's take this structure. Cut it from there. And in here, we're going to define it internally for now. So I'm going to remove all these comments because I really don't need all of this stuff in here. This is just internal code. I don't really want to worry about all of that. right? So let's just move, actually, let's just move this up here. Take this Boolean down here so we can pack this a little bit more efficiently, right? Move these vector3s here, move the type there, probably down here, actually. Yeah, okay. So let's do K camera internal, or I guess we could actually do K camera data, right? I think that makes more sense. K camera data. That's how we're going to represent it internally. So we'll have K camera data here. We're going to have an array of those. And then we're going to have cameras, right? So we're going to have a max count of those, and then we're going to have an array set to that size. And then the only thing is, how do we just determine a free slot versus a occupied one? We could just use existing fields to do that, I guess. Or I could use flags. Maybe we should use flags instead of having an isDirty. I hate Booleans like this, right? Let's do this. Let's do type def enum K camera flags, right? And there's only a couple flags that we're going to need for now, but we could potentially expand this, right? So K camera flag, and the first thing is none, I guess, right? That's going to be 0. K camera flag, and then we'll do dirty, or isDirty. isDirty, sure. And that's going to be oh wait, I want to do this bit shift by that by 0. I think that's what I actually want. Yeah. Okay, so the next one is going to be K camera flag. What was the other thing that I was saying? Is free, I guess, right? And we could just do that. Yeah. Okay. So we can eliminate this and just do oh, you know what? This should be, should that be flag bits? This should probably be, right? Bit. And then we'll do a type def U32 K camera flag bits. Right, and then we can come down here and just do K camera flag bits flags. Right, and that just kind of makes it obvious what that field is and how it's going to be used. So what we'll do down here is in our system initialization, we will obviously have to set up our struct requirement. So we'll need that. It's going to be the size of camera system state. And then the array requirement is going to be the size of K camera data. And that's going to be times the max camera amount. And that's all we need. We don't need the hash table requirements. So we just need struct requirement plus array requirement. And that is going to be how our memory block is formed, right? So we're going to allocate all of this at once. We're going to allocate enough storage for this state. And then the block right after that is going to be the memory that this array is held in. So that way we don't have to allocate it separately. So this is going to be state pointers, K-camera state. That's fine. We probably, I suppose we could make that a little bit more type safe. I'm not going to save off the config. I am going to save off the max camera count and typed config max camera count. Do we not have typed config? Yeah, okay. So we have max camera counts, and then array block is going to be the state plus the struct requirement. And then the cameras is actually just going to be the array block that we calculated here. We don't need the hash table block. We don't need hash table create or fill. Invalidate all cameras in the array. So this is just going to be, we can just get that from state pointer rather, max camera count. And the only thing that we're going to do is, instead of having some sort of ID, we are going to do, we're going to set flags. And we're going to do flag set, right? And we're going to do state pointer cameras sub I flags. The flag we're going to do is K camera flag is free, and we want to set that to true, right? And we don't have to do anything else aside from that. So here, mark all slots as free. Okay, and then default camera, we don't actually have that set up anymore, but we do need to actually set one up. So we'll have to come back to that because we actually don't have a way to grab a new camera handle. It's about time for me to get on my own refactor tractor. Simple things are getting too complicated over here. Yeah, Potham, I feel that. That's kind of the reason why I was just like, I didn't really want to do this stuff before starting the game, but I was like, man, if I get really far into the game, this kind of crap is going to be super hard to refactor across a large game code base. So, you know, it's like better off just doing it now, quite honestly. Let's see. Seems we need a tool to generate KMT files for model as some models that have many textures. We do have a tool for that, actually. Yeah, we actually have an importer for that. Yep. So you're limiting to 256 cameras. I guess that makes sense. Some games put multiple cameras in their scene through, though especially with fixed angles, then switching between them. Yeah, exactly. But like, are you really ever going to need more than 200? Are you ever going to need more than 100, right? But the cool thing about this is because we've type defed it, literally anywhere that I use K-camera, all I have to do is change that type def and it just works. So I don't even have to worry about that. Okay, so we need a function. I'm just going to declare it here for right now. We're going to do K-camera. And we're going to do get new camera. And we're going to pass to it the K-camera system state. And I think that's actually all we need, right? So all we're looking for is just to get a new camera, right? To create a new one from a free slot. So all we're going to do is for, actually, yeah, U32, no, U8 I equals 0. I is less than state max camera counts plus I, right? I suppose I could use like U32s internally here, but I don't want to make it so that you could technically configure more cameras than we actually support, right? Because that's just kind of dumb. So we're going to do if states cameras sub-I flags, and we actually have a function to check this for us very easily. So flag get, right? So we want to just do that. So we want to check against that rather. And then flags, and then we want to check for K camera flag is free. So if that is free, then we want to use it, right? So we're going to return I. And since that's just the type def of a integer, it just works, right? Now, if we get all the way to the end here, we're going to do K error. Let's do camera. Let's do K camera system. The internal array is full. Max camera count equals, we'll shove that in here. Expand this in configuration. Right, and we'll put in here states max camera count, right? And we will return 0. We should probably also say that returning default camera instead. Okay. Thank you guys for the follows. I really appreciate that. Welcome. What is the K API thing at the beginning of functions definition, and is it necessary? Yes, it is absolutely necessary. So what this is this is to tell us to export or import symbols depending on how we're actually using it, right? Whether we're defining this in a library or whether we're defining it in a consuming executable. And so we either for GCC/Clang, it either changes the visibility of that symbol to default, right? Instead of, hidden, which is what we actually defined as our default. Or in Visual Studio, for those of you that are used to MSVC, it's, decal spec export, or what is it? Export and import, I think. Or DLL export. I can't remember exactly what it is. It's defined in here. Decal spec DLL export, right? So for Microsoft's compiler, it's that. So whether we're importing or exporting, that's set by how we're actually building the particular code that we're looking at. But that's what that does. It's just a symbol import or export, and we have that set across all the various compilers that we support, so that it's consistent across the board, because we don't export symbols by default. So what this does is essentially makes it usable to any other library that is, or any other bits of code that are loading up this particular library of code, so that they can actually see this symbol and load it up and use it. Okay. Thank you for the follow. Appreciate that. Welcome. Okay, so default camera. So what we're actually going to do here is we're actually going to go ahead and use this get new camera, right? So let's actually just do this. K camera default camera equals get new camera, pass along the state pointer, and that's it, right? And then return. Oh, you know what? There was one thing I forgot. Since we are checking by this free flag, before we actually utilize that, we actually need to do a flag set on that. So states cameras sub-I flags. K camera flag is free bit to false. And then we actually need to set that equal to that, right? So unflag it, if you will. as being free. Okay. So we've got that. So I guess what we could do is we'll do return default camera equals 0, right? Which we know is going to be true. We just need to actually use this so that it actually gets created, right? So the next thing that we should probably do is set up some default properties of the default camera, right? I'm going to mark that as a to-do because we can't actually do that yet until we specify the system a little bit further. So camera system shutdown. There's basically not much we need to do here because we're not maintaining pointers. We're not doing any dynamic allocation of any kind. The only array that we actually have was allocated as part of the system state itself. So we don't actually need to do anything here except that, right? So I'll do a note. Nothing in the system needs shutting down. As there are no dynamic allocations done or resources held by this system. Just a little note to myself in case I come back later and go, oh, I forgot to actually fill that out. There's actually nothing we need to do with that. Okay, so we have this acquire function here, which, frankly, I'm just going to throw this out because there's not much in there we actually need to do, right? So like all this lookup stuff that we were doing in the old system, gone. So what we need actually, oh, you know what? Let me fix something in the H file I just realized was here. I don't want to do camera system create. I just want to do camera create. Right? And then camera destroy. So that's going to be the same thing here. Camera create and camera destroy. Okay. So let's see, get defaults. We actually have that here as well. So I'm actually just going to copy this up here. Get rid of this and do that. And then here we are just going to do return 0, which is 0 is the default. What we could do is we could do, what is it, default? Oops, default K camera. We're going to kind of do that no matter what, honestly. So actually we don't even need any of this stuff, right? We could just do that. Thank you for the follow. Clutch Nova, how's it going? First time chatter. Thank you very much for the follow. I appreciate that. Okay, so we have release. We need this creates. Oh, you know what? That is going to be... Yeah, let's grab both of these functions. Right, so create is going to be there. Let's just knock out destroy real quick since it's going to be relatively simple. I don't need this. Okay, so what we don't want to do here is we basically want to say, and actually I can do if camera equals default K camera return, right? We don't want to destroy the default camera ever. right? Now, we don't need any of this stuff, right? We can get rid of all of that. All right, we don't need the reference. You know what? I'm just going to write this from scratch. Okay, so if we're not on the default camera, then what we need to do is we need to do k camera data. And we're going to do data is equal to the address of state pointer cameras sub camera, right? Now, you might have identified a problem with this. If camera is greater than or equal to state pointer max camera count, then we're going to throw an error. Tried to destroy a camera that is out of range, you dingus. Right? Now, once we've gotten past all of the sanity checking there, now we can actually set some of the data, right? So the only thing I think that we actually need to worry about is the flags, right? So what we're going to actually do is k0 memory data, and then do size of, and we're going to do k camera data. And then we're going to do, we actually had it up here. We actually had this up here. So we're going to do data flags, data flags, right? So we're going to set the free bit to true, right? So mark it as free. Nothing to destroy or release, just zero it out. Right, and I probably don't need to be this explicit with like my comments and stuff, right? But like, for those of you who come back in here and read the code later, it might make a little bit more sense because I'm doing that. Now, one thing we probably might want to think about doing anyways, is actually having some sort of getter for an existing camera, right? Where we do sort of these checks all in one place so that we don't have to kind of keep repeating this code all over the place. So I'm actually going to take this whole thing, and I'm going to go up here and I'm going to make another static function. And we're just going to do B8 k camera. Oh, this needs to be static. K camera is valid, right? So in range and not default. Keep spelling default wrong. Okay. So all we do is this. So if it's the default camera, we return false. If we don't have the state pointer, we return false. Right? And then what we can do here is if we have an error here, we can return false. And then we actually don't need to do any of this stuff here. We could just return true in this case. And so now we can do k camera is valid down here instead of having to worry about all this stuff. So if k camera is valid camera, then we can do all this. So actually we can just take this logic here, hoist it up there, and get rid of all of this. And that's just kind of like the pattern that we're going to follow going forward, right? So let's do K-camera create, right? That's going to be the next one. So for this guy, the first thing that we need to do is if we don't have a state pointer, we're kind of up the creek without a paddle, right? So if not state pointer, return default K-camera. We should probably also K-error. We'll do function called before system was initialized. All right, and so for the function, we'll just do function like that. That should expand out correctly, I think. Yeah, okay. Okay, so we boot out immediately if that is not valid. And then the next thing that we need to do is we can actually just do K-camera, new camera, new cam we'll say, equals get new camera. And we'll want to do state pointer to that, right? And then I suppose we could do a check, right? If K-camera is valid, new cam, right? Then we can do the things, right? So we can do, we'll do data, right? We'll go ahead and grab that, and then we'll do, this is going to be new cam, so that we don't have to keep indexing that. And then we'll do data. So flags would already be set here, right? So type equals type. Data position equals position. Data rotation. Euler rotation equals rotation. Data FOV equals FOV. Data near clip equals near clip. Data far clip equals far clip. Oops. And then what we'll also want to do is we'll want to do data flags equals flag set data flags. And then we'll want to do K-camera flag is dirty bit, and we'll want to set that to true, right? So we'll mark as dirty, so it gets recalculated on the next pass, right? Because we want to take all of the calculation that we do for all of our matrices, we only want to do that once. You know, we only want to do that whenever it's actually dirty, right? We don't want to have to do that multiple times. And so there's two ways we could do that. We could do it on demand, which is probably what I'm going to do. Or we could do it as part of an update loop. But the update loop means you have to check every single one, which is kind of lame. So I think I'm probably just going to do it on demand. Let's see. Okay, so that is creates pretty straightforward stuff. Get default, we've already done that as well, so we don't need that. Okay, now comes the fun part. So now we've got to actually fill out all of these new functions. Now, we already have the implementation for a lot of these guys, so I'm probably going to wind up going over to the C file in camera.c and pulling the implementation of a lot of those. But we're not there yet. So let's go down this way and axe all of those. And I hate that it does. I wish I could do like a, just repeat that one action, but it doesn't because it like does a couple of other things in here. I guess I could just do, I guess I'll just do it manually because I don't really want to find and replace that either. That seems risky. I suppose I could do, that still didn't work. Wow, okay. Okay, I figured pasting it would probably be a repeatable action, but apparently not. It's probably something stupid I'm missing. Still learning things about Vim every single day. Even though I've been using it for years, I'm still constantly learning new ways to do stuff with it. Oops. So let's do that. Okay. So, essentially what these are all going to do is they're all going to kind of follow this pattern a little bit. So all we really need to do is, if it's valid, we're just going to do, instead of grabbing this, right, we're going to return position, right? So it's still pretty simple, but like we have, a little bit of validation that we can do there. Now, if it is not valid, we're going to have to return something, right? So I suppose at this point we could do, let's see. Do I want to do a warning? I guess I could do a k-warn. Let's do function name, invalid camera, passed, returning default value. And then I'll do function, right? And then I'll do return vec3 0. Why is that not? Okay, there we go. So that way I don't have to keep kind of retyping the same thing over and over. Oh, that's get position. Yeah, okay, get position. That makes sense. Get Euler rotation. It's going to be the same thing. So that's going to be, whoops, crap. Euler rotation. So I guess we'll do, sort of the gets first. So FOV is going to be simple as well. FOV. And then this is just going to be, what do we want as like a default for I suppose we ought to do like 0. Right? Keep it super explicit. Like we're going to return rubbish. So near clip. So this needs to be near clip, far clip. All right, and then we have view, transform, and projection.
Good evening, Travis. Good evening, chat. Smile.
Smudge, good to see you. How have you been? Thank you for the tier 1 sub for 15 months. Currently on a 11-month streak. I really appreciate the support, and thank you so much for that. That means a lot to me. I'm glad to see you. Hope you're doing well. Kind of missed what you were doing, but I think you'd X'd the semicolon, which put it in your yank buffer, replacing the open and close braces. Yeah. So what I was trying to do was, like, I had a situation. I'll just undo it here. I had a situation here where I was like, I want to replace this with essentially brackets, right? The problem is like, even if I hit S, right, which is just the substitute, and I do this, but I also press enter, there's another action that takes place that automatically tabs me over. So the problem is I can't even repeat that, right? I can't even go, oh crap, I don't have another example. Here, if I go down to this one, right, and I just hit repeat, all it sees is like the last thing that I did was like an enter, because of the way that it handles tabbing over. So that was the thing I was getting annoyed about. Yeah. Quick question. I got laid off and I got a lot of free time. Well, I'm super sorry to hear you got laid off. I have been there and done that, so I understand the pain. Sorry to hear that though. But you do have a lot of free time. How long do you think it will take for me to be good at Vulkan if I fully commit to this? That is a loaded question, right? Because that depends on where your skill is. How good are you with C or C++, right? That's a big barrier to entry for sure. Have you done graphics programming before? Do you understand the concepts, right? If you're having to learn all that stuff as well, that's going to be much harder for you. I'm not saying it's impossible, but trying to learn Vulkan and trying to learn graphics programming concepts at the same time is probably not the best idea. So I would say if you don't do graphics programming or you're not familiar with it, I would start with something simpler like DirectX 11, or what I usually suggest is OpenGL, right? Just to learn the concepts of it. And then once you understand that and you've written a couple renderers, and I do mean a couple, in OpenGL, then switch over to Vulkan. If you're doing all of that, and you could do it like full time, depending on how quick you learn, and again, depending on a whole bunch of different variables, I don't see why you couldn't, potentially have that on lockdown after like a year or so. But I assume you probably don't have that much time. It's not something you can do in like a week, I can tell you that much. Let's see. Got to know math too, like linear algebra. Yeah, that's a big one, obviously, right? Like all the math stuff that we had to do for this, like, because I also wrote all that crap from scratch. I mean, you could get away with not knowing that stuff if you use like GLM or something, right? But yeah, it is not something that you can just like pick up and run with in like a month or two. Yeah, I'm not trying to burst your bubble, but I also don't want to set you up for disappointment, right? Totally doable, but it depends on where you're at. I hope that helps. Learning Vulkan and C at the same time sounds like something masochistic I would not recommend. Yeah, I would not recommend doing that. Yeah, if you don't have a decent command on either C or C++, you got to do that first. And the way that I say to always do that is write a string processing library from scratch, not using any of the standard library stuff. And if you do that, especially in C, without using like any built-in stuff whatsoever, you write all of it from scratch, you'll be pretty good with the language by the time you're done. But yeah. Doing great lately, just been super busy, haven't been around much lately. How are you? How's Kohi? I'm doing great, thank you for asking, and I totally understand being busy. Been there, done that many, many times, especially lately for me as well. But yeah, I mean, things are going pretty well. So we actually have, we've been working on our Bespoke game renderer or application renderer. We have it up and running, but I'm doing a little bit of additional sort of refactoring around that as well. But we do have, our program back up and running with all of our lighting and all of our stuff back up and running as you would expect, right? With our cascading shadow maps and stuff. All that stuff's been fixed. So I'm just in the process now of revamping the camera system and ripping out the old viewport system and making this a lot more robust than it used to be, and getting rid of the separate and kind of pointless viewport system. So yeah, that's kind of where we're at. Let's see. Are you going to use your own immediate mode GUI? So I'm doing a retain mode GUI right now, which is what I have at the moment. I plan on actually writing both. Because the way this engine is designed, the UI system itself is a plugin. So you don't even have to use it. You can write an entire game without using it. And that's the idea. So the idea is that eventually we'll have a retain mode plugin for UI and a immediate mode plugin for UI, and they each have their own strengths and weaknesses, right? So you'll have to kind of weigh that out when you pick which one you're going to use. But yeah, that is something that we're going to be doing at some point. It's going to be another one of those things. I'll write it when I need it. But yeah, that is on the to-do list for sure. Just don't know when I'm going to get to it. Okay, so here, get view, we have view matrix there. However, we need to do a little bit more checking when it comes to the view. So in this case, we're going to do mat for identity, right? If we have an error situation, that's going to be how we default there. And then before we return the view matrix, this is kind of what I want to, this is kind of what I wanted to talk about and one of the reasons that I wanted to do it this way. So whenever we get the view, the transform, or the projection matrix, we're going to run this check. And we're basically going to say, is this dirty? Meaning some update has changed. Either we changed the FOV or we changed the position or the rotation or any of those properties, right? Have we changed any of those properties? If we have, let's regenerate everything, right? Let's regenerate the transform, the view matrix, which is really the view matrix is just the inverse of the transform, so that's not a big deal. And regenerate the projection matrix. And so what we're going to have is, I'm actually going to kind of just do this here in line and we'll move it later. Is we're going to have a, I guess, should I call it regenerate matrices? I think that makes sense. And so to this, obviously we'll pass, I'm actually going to pass the state. So K camera system state and K camera, let's see, should we, I'm going to need the, yeah, I'll just do camera for now. I was debating whether or not to pass the camera data, like a pointer to the camera data, but I think I'm just going to get it here. So K camera data equals the address of state cameras sub camera, right? And we're not going to do a check here for is valid, right? We're going to rely on anything that's calling this to do an is valid check. I suppose we could not do that, right? But like, I feel like this is an internal function. It should just be able to assume the data being passed to it is valid. So this is what we're going to want to do. We're going to want to go to camera C, and we have actually functions in here. I'm going to find it. Here we go. Recalculate view, right? So we'll just take this. We'll do recalculate transform. And then we'll have view is just inverse transform, right? And so here we have data, right, being passed to those things. Let's see. Data and data. Okay. So here's the transform, and then we do the view, right? So we just kind of get the view matrix almost for free, right? And then we need to recalculate the projection matrix, right? And that is going to be, what did I call that? What did I call that? Generate projection matrix. That's what it was. Oh, you know what? I don't think I added this to the header file. Oh, I did. Okay, cool. Let's go back here. Let's paste this in. So we'll do data projection equals this, right? And so, oh, you know what? That was one bit that I was missing, was the sort of the viewport rectangle. We don't actually have that in here. I need to add that. So we need one more property here. I'm going to put this up here since it's technically a 4-element array. We're going to do rect 2di, and we'll do VP rect. We'll just use that, right? So VP rect default camera. Shoot. Okay. That probably should be here. Right, so we have data VP rect equals VP rect. So there's just one more thing we have to actually take in. Glad I discovered that now. So this has to be here. Rect 2di, VP rect. And this is just going to be VP rect. The viewport rectangle. And we're going to say i.e. the dimensions of the camera's face, right? That's essentially like it's the size of the lens, I guess you could kind of think of. Okay, so we have that. I just realized this didn't have that in front of it. Neither did this. Okay. So we have the VP rect there. So we want to do data VP rect, data FOV, data near clip, data far clip. Okay, so projection matrix type. We actually need to switch on that, right? So projection matrix type. So we'll do matrix type. We're going to do, I'm just not going to set it to anything, right? We'll do a switch. So we'll do data dot type, right? And then fill this out. So here we're going to do matrix type is equal to, for 2D, it's going to be projection matrix type. Why is it not? Oh, render projection type. I probably ought to change that. Okay. Yeah, that's kind of poopy. I don't like that. All right. And then why is this bleating so hardcore? projection matrix type. Don't we have... Where is this? Oh, it's renderer projection matrix type. That's kind of lame. And verbose. We don't really need all that. While we're in here moving stuff around anyway. Yeah. Let's do that, right? And we'll just do matrix type for this one. And then we'll go to type utils. And I'll change it here as well. Matrix type, right? And then matrix type, and there we go. Okay, so that's fine. That's probably going to throw errors elsewhere, but I like that version of it better. Okay, so we have that one there, and then for this one, instead of orthographic, we do perspective, right? And then I'm also going to have this be the default so that we don't have some sort of weird situation otherwise, right? So now we can use matrix type, right? This just needs to include the render type utils, and there we go, right? So we recalculate the projection matrix based off the camera type. So now all we have to keep track of is we don't have to worry about creating this or this, or remembering which one to create or all the properties to create it. All that stuff's just held by the camera now. One more thing, the default actually needs to be set up with some properties. So I actually want to go to I want to go here and take sort of the default world camera stuff and use that as the default camera stuff here. The properties of the default camera, right? So K camera data, default cam data is the address of state pointer cameras, default K camera, right? And so we can get rid of that. And actually, I'm kind of wondering now, maybe we should just do a camera create instead of doing all this, right? Because we actually have the camera create. Right? So we could do K camera type. K camera type. We want a 3D one as our default. And then let's see, it's a viewport rectangle, so we're just going to define a default size here. So we're just going to do 0, 0, 1280 by 720. And then we'll do, what was the next thing? Oh, this has got to be a rec 2di. So what was it? Position, Euler rotation. Okay, so we can use these. Actually, I'm going to do, you know what? I'm going to do vec3 0 for both of those. Let's see. Okay, so the default FOV will use 45. We use 45 degrees for that. So we'll do degrees to radians, 45.0 F. And then near we'll do 0.1 F, and far we'll do 1,000. And I think that might be it. Yes. Okay, so now we don't need any of that stuff, right? Cool. All right, so that's going to do it for the stream this time. I actually ran over a little bit, so it's definitely time to shut it down. So yeah, I just need to find somebody to raid. I really appreciate you guys being here and hanging out with me. Hey, Eric over there over on the YouTube side, how's it going? Pop culture, I love the name over there. That's great. It clicked what that actually was when I read it out loud. Quick OpenGL question you might know. Do you think it's worth caching the ID location uniforms, or is it fine to get the location each time you set it? I always cache them, because it's one less thing you have to run back and forth, to the GPU for. So I always cache it. Your NeoVim looks so much better than mine. I'm jealous. Here, I will, first time chatter, by the way, I will drop a link to an article that describes what I use, how I have it set up, and gives you a link to the config. It might be a little bit out of date, so you might have to mess with it a little bit, but most of it is correct. All right, so let me find somebody to raid. Just going to scroll through the list real quick. I see a couple of possibilities already, but let me change the category. Kind of hoping to find something semi-related, but we'll see. Okay. I think I see who we're going to go with. Yep. Okay. I don't think I've rated him before, but we're gonna go over and see what Cricket's up to. Looks like they're polishing some controls on the game they're making, so we're gonna see what they're up to. And yeah, thank you guys so much for being here. I really appreciate it. Thank you again for all the follows and the support tonight. I really, really appreciate that, guys. Yeah, it's been a lot of fun. We're gonna pick up on the next stream, which is next Wednesday, actually. So I'll look forward to seeing all you guys back here. Thank you again for being here. If you haven't already, I would really appreciate a follow and or a sub over on the YouTube side. But I think a lot of you guys have already done that. So yeah, that's gonna do it for tonight. Thank you guys for being here. I'll see you guys later.